Have you ever wondered if what you perceive is the same as what others perceive? This question may seem simple at first, but it unravels an intricate tapestry of human cognition and perception. Perception, in essence, is our interpretation of the world around us derived from our sensory information. But here's the twist. It is not a universal experience. Our brains work tirelessly, acting as masterful artists, painting our reality based on a myriad of factors. These factors can range from our past experiences, our culture, even our current mood. All these elements intermingle, shaping and reshaping the way we interpret our surrounding environment, leading to an intriguing idea, the perception paradox. Let's delve into this paradox a bit further. Remember the viral sensation of the blue and black, or was it white and gold dress? It swept across the internet, dividing friends, families, and colleagues into two distinct camps. The simple fact is, the same image was perceived differently by different people. This instance is a classic example of the perception paradox. The dress phenomenon brought to light a crucial understanding. Our perception of reality is not always an accurate reflection of the world around us. It's a personalized, subjective interpretation, and sometimes it can be drastically different from someone else's. This leads us to the fascinating realm of optical illusions. These are not just quirky images designed to confuse us. They are, in fact, a manifestation of the perception paradox. Optical illusions are instances where our brain interprets sensory information in a way that creates a perceived reality that is different from the actual state of the world. So, is it possible that our brains could be tricked into seeing something that isn't there? Could our perception be so malleable that it bends and twists our reality? The answer is a resounding yes. Welcome to the fascinating world of optical illusions. Now, let's delve into the science behind these intriguing visual phenomena. At the heart of optical illusions are two key players, our eyes and our brain. They work in tandem to process visual information, but sometimes they don't exactly see eye to eye. This mismatch can lead to the creation of optical illusions. Let's break this down. Imagine you're looking at an image. The light from that image enters your eyes and hits the retina, a light-sensitive layer at the back of the eye. This light is then converted into electrical signals and sent to the brain via the optic nerve. It's here that the magic, or should we say the illusion, happens. Our brain interprets these signals to create a mental representation of the world around us. But here's the catch. The brain doesn't always interpret these signals accurately. And this is where the concept of optical illusions comes into play. Take depth perception, for instance. It's the ability to judge the distance of objects and the spatial relationship between them. But in a two-dimensional image, there's no real depth. Our brain, however, is wired to seek depth in everything it sees. So it uses cues like size, perspective, and lighting to create a sense of depth where there isn't any. This can result in some pretty mind-bending illusions. Then there's color perception. You'd think that the color you see is the color it is, right? Not quite. The color of an object can appear different depending on the lighting conditions, the color of the surrounding objects, and even your own expectations. And let's not forget perspective. Our brain uses perspective to make sense of the world, but it can be easily tricked. An object can appear larger or smaller, nearer or farther, depending on its context and the angle at which it's viewed. So, in essence, optical illusions are nothing but our brain's interpretation of what our eyes see. You might be surprised to know that there are several types of optical illusions. Firstly, we have literal illusions, which create images different from the objects that form them. Simple examples include mirages that you might see on a hot day. The shimmering water you see in the distance on a highway isn't actually there. It's an illusion created by light bending or refracting because of temperature differences in the layers of air above the road. Next, we have physiological illusions. These are the effects on the eyes or brain of excessive stimulation of a specific type: brightness, tilt, color, movement, and so on. For instance, after staring at a bright light, you may see after images when you look away. Finally, we delve into cognitive illusions. These are the result of unconscious inferences. Sounds complex? Well, it's simpler than it sounds. Essentially, these illusions occur when our brain tries to make sense of what our eyes see based on what it expects or predicts. A classic example is the Necker cube, a two-dimensional drawing that our brain perceives as a three-dimensional cube. We can't help but see it as a cube because our brain is wired to interpret two-dimensional drawings as three-dimensional objects. Each of these types of illusions provides a unique glimpse into our perception and how our brain processes information. Literal illusions show us how our physical environment can trick our senses. Physiological illusions demonstrate how our bodies respond to intense stimuli. And cognitive illusions reveal the underlying assumptions and predictions our brains make to help us understand the world around us. Isn't it fascinating how our brain can be tricked in so many different ways? Optical illusions are not just fun tricks, they have a significant impact too. They're far more than mere party tricks or fodder for viral social media posts. They found their way into a multitude of disciplines, from art to architecture and even psychology. Let's start with the world of art. Artists have been employing optical illusions for centuries, from the Renaissance masters to modern street artists. They use these visual tricks to make flat canvases seem three-dimensional, to create a sense of motion where there is none, or to challenge our perception of reality. Think of M.C. Escher's Impossible Staircase or Salvador Dali's Melting Clocks. These works not only mesmerize us, but also force us to question our perception and the nature of reality itself. In the realm of architecture, optical illusions play a crucial role too. Architects manipulate lines, angles, and shapes to create structures that seem to defy the laws of physics. They use optical illusions to enhance the aesthetic appeal of buildings, make small spaces appear larger, or to create a sense of depth and dimension in a flat facade. Now let's talk about psychology. Optical illusions are incredibly useful in understanding how our brains work. They've given psychologists valuable insights into perception, cognitive processes, and the brain's knack for filling in gaps of information. Illusions like the famous Rubens vase or the Canisa triangle demonstrate how our minds prioritize certain visual cues over others, revealing the shortcuts our brain takes in processing visual information. Moreover, optical illusions can help in diagnosing and understanding certain neurological and psychiatric conditions. For instance, patients with schizophrenia or Parkinson's disease may perceive illusions differently, providing clues about the underlying changes in their brain function. In essence, optical illusions are not merely about deceiving the eye, they're about understanding the very roots of our perception, the interplay between what our eyes see and how our brain interprets it. They're about exploring the limits and capabilities of our own cognition. Optical illusions, therefore, offer a glimpse into the complex workings of our brain. So, what do these mind-bending illusions tell us about our perception and reality? Well, as we've journeyed through the intriguing world of optical illusions, we've discovered that our perception of reality isn't always as clear-cut as it seems. It's a paradox, a delightful dance between the mind and the eyes, where what we see isn't always what is there. We've delved deep into the science behind optical illusions, shedding light on how our brains interpret visual stimuli. It's a fascinating process, isn't it? Our brains are constantly interpreting and making sense of the world around us, and sometimes they take a few creative liberties. This leads to the formation of optical illusions, those mind-bending images that trick us into seeing something that isn't there or is different than it appears. We've explored the common types of optical illusions, from the classic ambiguous images that can be perceived in two or more ways, to the puzzling paradox illusions that defy logic and challenge our understanding of space and form. We've even looked at the intriguing physiological illusions that occur due to the effects of excessive stimulation of a specific type on our eyes or brain. Each type a testament to the complexity of our visual perception system, and of course we've discussed the impact of these illusions, from their use in art and entertainment to psychological studies and even in understanding and treating certain neurological conditions. They're not just fascinating phenomena, but also powerful tools that can help us better understand our brains and how they process information. So what's the takeaway? Perception is indeed subjective. It's influenced by various factors, and at times it can lead us down a rabbit hole of mind-bending illusions. But that's the beauty of it, isn't it? It's a reminder of the complexity and marvel of the human brain, a testament to the wonders of perception. Remember, perception is reality, but not all that is perceived can be believed. Keep exploring, keep questioning, and keep marveling at the wonders of the human brain.